Giant solar flares, more properly known as coronal mass ejections, are enormous magnetic outbursts on the sun that bombard Earth with a torrent of high-speed subatomic particles. Earth's atmosphere and magnetic field negate the potentially lethal effects of ordinary flares. But while looking through old astronomical records, Bradley Schaefer of Yale University found evidence that some perfectly normal-looking sun-like stars can brighten briefly by up to a factor of 20. Schaefer believes these stellar flickers are caused by superflares, millions of times more powerful than their common cousins. Within a few hours, a superflare on the sun could fry Earth and begin disintegrating the ozone layer. Although there is persuasive evidence that our sun doesn't engage in such excess, scientists don't know why superflares happen at all, or whether our sun could exhibit milder but still disruptive behavior. And while too much solar activity could be deadly, too little of it is problematic as well. Sally Baliunas at the Harvard-Smithsonian Center for Astrophysics says many solar-type stars pass through extended quiescent periods, during which they become nearly 1% dimmer. That might not sound like much, but a similar downturn in the sun could send us into another ice age. Baliunas cites evidence that decreased solar activity contributed to 17 of the 19 major cold episodes on Earth in the last 10,000 years. Rogue black holes. Our galaxy is full of black holes, collapsed stellar corpses just a dozen miles wide. How full? Tough question. After all, they're called black holes for a reason. Their gravity is so strong they swallow everything, even the light that might betray their presence. David Bennett of Notre Dame University in Indiana managed to spot two black holes recently by the way they distorted and amplified the light of ordinary, more distant stars. Based on such observations, and even more on theoretical arguments, researchers guesstimate there are about 10 million black holes in the Milky Way. These objects orbit just like other stars, meaning that it is not terribly likely that one is headed our way. But if a normal star were moving toward us, we'd know it. With a black hole, there is little warning. A few decades before a close encounter, at most, astronomers would observe a strange perturbation in the orbits of the outer planets. As the effect grew larger, it would be possible to make increasingly precise estimates of the location and mass of the interloper. The black hole wouldn't have to come all that close to Earth to bring ruin. Just passing through the solar system would distort all of the planet's orbits. Earth might get drawn into an elliptical path that would cause extreme climate swings, or it might be ejected from the solar system and go hurtling to a frigid fate in deep space. Flood basalt volcanism. In 1783, the Laki volcano in Iceland erupted, spitting out 3 cubic miles of lava. Floods, ash, and fumes wiped out 9,000 people and 80% of the livestock. The ensuing starvation killed a quarter of Iceland's population. Atmospheric dust caused winter temperatures to plunge by 9 degrees in the newly independent United States. And that was just a baby's burp compared with what the Earth can do. 65 million years ago, a plume of hot rock from the mantle burst through the crust in what is now India. Eruptions raged century after century, ultimately unleashing 250,000 cubic miles of lava. The Laki eruption 100,000 times over. Some scientists still blame the Indian outburst, not an asteroid, for the death of the dinosaurs. An earlier, even larger event in Siberia occurred just about the time of the Permian-Triassic extinction, the most thorough extermination known to paleontology. At that time, 95% of all species were wiped out. Sulfurous volcanic gases produce acid rains. Chlorine-bearing compounds present yet another threat to the fragile ozone layer. A noxious brew all around. While they are causing short-term destruction, volcanoes also release carbon dioxide that yields long-term greenhouse effect warming. The last big pulse of flood basalt volcanism built the Columbia River Plateau about 17 million years ago. Divine intervention. Judaism has the Book of Daniel. Christianity has the Book of Revelation. Islam has the coming of the Mahdi. Zoroastrianism has the countdown to the arrival of the third son of Zoroaster. The stories and their interpretations vary widely, but the underlying concept is similar. God intervenes in the world, bringing history to an end and ushering in a new moral order. Apocalyptic thinking runs at least back to Egyptian mythology and right up to Heaven's Gate. More worrisome, to the non-believers at least, are the doomsday cults that prefer to take holy retribution into their own hands. In 1995, members of the Aum Shinrikyo sect unleashed sarin nerve gas in a Tokyo subway station, killing 12 people and injuring more than 5,000. Had things gone as intended, the death toll would have been hundreds of times greater. A more determined group armed with a more lethal weapon, nuclear, biological, nanotechnological even, could have done far more damage. Catastrophic climate change. Consider the catastrophic impacts of climate change that are unfolding. Extreme weather events are not just more frequent, they're more devastating. Hurricanes are more intense, with winds and floods displacing millions. Droughts are longer and harsher, turning fertile lands into deserts, as seen in the expanding Sahara. These changes disrupt ecosystems, diminishing biodiversity essential for ecological resilience. Rising sea levels threaten to engulf coastal cities worldwide, displacing populations and causing unprecedented refugee crises. The interconnected effects of these changes could lead to a collapse in global food systems as crop yields falter under the strain of altered weather patterns and water shortages. Nuclear war. The specter of nuclear war casts a long shadow over global security. Today's nuclear arsenals hold the power to destroy human civilization multiple times over. The detonation of nuclear weapons would not only cause immediate destruction, but also long-term environmental consequences. Radioactive fallout could render vast areas uninhabitable, devastate the ozone layer, and trigger a nuclear winter that would lead to global crop failures. The societal impact would be profound, as governments struggle to maintain control, with widespread panic, lawlessness, and a breakdown in basic social services. Ecological catastrophe. Ecological degradation is accelerating. Forests, vital as carbon sinks, are being cut down at alarming rates. The Amazon rainforest, often described as Earth's lungs, is being reduced by thousands of square kilometers annually. Wetlands, crucial for purifying water and providing wildlife habitats, are disappearing, affecting natural water cycles and species dependent on these environments. Coral reefs, the nurseries of the seas, are dying off, which could lead to the collapse of marine life populations. These ecosystems are critical not only for wildlife, but for human economies and health, underpinning industries from tourism to fisheries. The loss of these natural resources could lead to economic declines and contribute to global instability. Artificial intelligence. Artificial intelligence could lead to unprecedented advancements in technology, economy, and society. However, the risks it poses are equally profound. An AI with misaligned goals could execute tasks that are detrimental to humanity, or it could develop capabilities that humans cannot control or counteract. The rapid development of AI technologies requires equally swift and thoughtful governance and ethical oversight to prevent scenarios where AI's decision-making processes are not fully understood or predicted by humans.